And now I invite Dr. Sanjay Arora to give a brief intro about ANRCM and what are its objectives.
Thank you, Dr. Vikas. First of all, I want to wish everyone the happy Foundation Day of ANRCM, and congratulations to those who are involved. And am I audible?
Yes, I can hear you.
So the ANRCM, sir, as you are aware, that ANRCM was initiated in 2019 with 19 like-minded professionals who initiated this, and it was established on August 16th. Since that day, we are involved in many activities in academic sense as well as in developmental part also. The academy is mainly mandated to work for the cause of conservation, development and management, as well as sustainable use of soil, water, land, forest, and other natural resources. In this association, sir, presently we are 47 life members, and some of the students and researchers have joined us as an annual member, and we are also publishing a e-journal presently, and it is available freely online at our website www.anrcm.org. And we request the learned participants to contribute their articles. Although presently we are not having any NAS rating, but we are hoping that with the support of our chief editor, Dr. Ajay Bhardwaj, and Dr. Anshuman Kohli, and the editorial board which we have from different countries, surely we will be having a quality output of the papers, and there will be some impact of the research or the studies which are published. The academy is basically having our chief patron as Professor Dr. G.B. Singh sir, and we are getting constant support of and guidance from him. Dr. D.K. Sharma is our patron, and we are constantly in touch with him as he has vast experiences, and he is former director of CSSRI and fellow of NAS and emeritus scientist of ICR. And Dr. Y.P. Singh, our senior vice president, and Dr. T.K. Srivastava, our vice president, and Dr. Atul as president. So we are having a lot of experience behind us, and on the other hand, many of the young participants, especially the members, the executive members, as well as the life and annual members, are in the initial or mid phase of their academic career. And since last 4 years, the academy has organized seminars, symposia, conferences, meetings, mostly online mode. Although we tried for a offline mode, a physical mode, we have got a huge response. 220 participants got registered in our physical conference, but due to COVID, it was not finalized, and later we rescheduled it on the Zoom platform, and we got overwhelming response from the participants, not only from India and from abroad also. We have organized several important days like World Soil Day or Population Day, as well as UNCCD call for Day for Conservation and Land Degradation. And these type of activities we are focusing, and we have also provided platform to the young participants to present oral as well as poster online. And in this endeavor, we have got support from our colleagues, Dr. Vikas, Dr. Kohli, Dr. Sanjay Swami, Dr. Bora, and the academy is trying to undertake some consultancy works and projects for monitoring and evaluation. Our retired professionals can go ahead with this, and we are presently going to start a publication on training programs, bulletins, manuals, and recently we have organized 2 online trainings. This is the first time which we have taken this responsibility of organizing training programs online, uh, where we are training on different aspects like soil and water management, soil conservation, soil health, and these kind of things. And we are fortunate that we are organizing this Foundation Day lecture on the 4th Foundation Day of the ANRCM, and fortunate to have Professor Bijay Singh, a learned scientist, a great academician, and a good writer and orator. And I am thankful that he has accepted our invitation, and I believe that the participants of today's program will be highly benefited from his talk. This is all about ANRCM. Sir, thank you very much.
Thank you, Dr. Sanjay, for a very comprehensive report on the society's functioning. Now I invite Dr. Anshuman Kohli to introduce the speaker, who is also the moderator of today's program, and to take the proceedings further.
Thank you, Dr. Vikas. So respected Dr. Bijay Singh sir, Dr. Arora, Dr. Vikas, Dr. D.K. Sharma, and I can see from the list of participants, we have one of my teachers also from PAU, Dr. Hadda. So very good morning to all of you, all other participants. Yes, I'm fortunate to have been selected to propose to introduce the speaker. And as we all know that Dr. Bijay Singh is known to all of us. He needs no introduction. I can see all of us, all the participants, we have often interacted earlier also, and all of you are aware with the profile of Dr. Bijay Singh. But formally, I would like to introduce, give a brief introduction, and then we'll begin with today's proceedings. So, first of all, let me say that I have known Dr. Bijay Singh since 1999 when I joined PAU as a research scholar, and I have had interactions with him. Even after completing my PhD, we often had interactions. I had contacted him for some referrals, and he has always been kind enough to support the PAU alumni, I think, and I have found him to be supportive and helpful to all the people in scientific fraternity whom he has known, he has interacted. In fact, I was fortunate to have him at my this university, Bihar Agricultural University in 2018, as a chief guest for the World Soil Day program. So, and thereafter also, as he just told me, that we had interacted in one of the international conferences organized by the Soil Conservation Society of India. Besides that, I always remember him as I have a gift from him when he visited PAU, as if it's in focus, this book which he had gifted to me when he visited PAU. So thank you, sir, for all your support. But just to have a formal brief introduction, I just want to say that Professor Bijay Singh is a soil scientist by training and is associated with Punjab Agricultural University, Ludhiana, as an INSA honorary scientist. He is a fellow of the Indian National Science Academy, National Academy of Agricultural Sciences, and the Indian Society of Soil Science. He served as ICR National Professor from 2006 to 2012 and INSA Senior Scientist from 2012 to 2017. He is decorated with several awards, including the Rafi Ahmed Kidwai Memorial Prize of ICR, the most prestigious award in agricultural sciences in India. The Fertilizer Association of India has honored him with its Silver Jubilee Award 2 times, first in 1984 and then again in 2001. The National Academy of Agricultural Science honored him with its Recognition Award in 2000 and Dr. N.S. Randhawa Memorial Award in 2008. He is the recipient of Professor K.S. Bilgrami Award 2009 and Professor Bal Dattatray Tilak Lecture Award 2014 of the Indian National Science Academy. And he has published over 150 research papers in journals of national and international repute and has more than 160 reviews, book chapters, technical papers to his credit. He served as Vice Chairman of Commission 3.3 on Soil Fertility and Plant Nutrition of the International Union of Soil Sciences during 2010 to 2014. He has been working on different aspects of rice wheat cropping system for more than 2 decades and has made useful contribution in the efficient management of fertilizer and crop residues. His contributions on nitrogen balance in soil plant system have led to better understanding for enhanced nitrogen use efficiency in rice wheat cropping system, fertilizer nitrogen related environmental pollution, and integrated nutrient management. Work on scheduling fertilizer N to rice and wheat through need-based fertilizer applications using chlorophyll meter and leaf color chart should greatly economize fertilizer nitrogen usage. Research on basic and applied aspects of integrated management of fertilizers, animal manures, green manures, and crop residues have provided scientifically sound directions for achieving not only sustainable yields in rice wheat system, but also for maintaining soil fertility for the future generations. And you see, there are no aspects on nitrogen that he has not touched. But then probably these days we are hearing so much about nano urea launched by IFCO in India. So probably that is something on which we haven't heard Dr. Singh. And maybe because this has been introduced very recently, but I very sincerely look forward to have his views on this novel nitrogen fertilizers, which obviously in the scientific fraternity, there's a lot of confusion about it. Sir, this is a challenge which I am throwing open to you. Maybe if you have any ideas on this, you can touch upon on this topic in your presentation or in your deliberation. So with these words, I would like to invite Dr. Singh for his presentation. Thank you.
Thank you. Thank you very much for a wonderful introduction. At this age, it gives you a lot of goosebumps that somebody still knows me. Dr. G.K. Sharma, Patron, Academy of Natural Resource Conservation and Management, Dr. A.K. Singh, President of the Academy, Dr. Sanjay Arora, members of the Executive Council, members of Academy, ladies and gentlemen. First of all, I'm thankful to Drs. Sanjay Arora, Sharma, and Kohli for saying so many things about the Academy and me, and it gives me a great feeling that I'm feeling very honored to be associated with the 4-year young Academy of Natural Resource Conservation and Management for being invited to deliver today the Foundation Day lecture of the Academy. This is the big honor which I feel at this age. Well, the Academy brings together professionals, the researchers, the students, and all those who feel concerned about natural resources, be it soil or water. We are already at a critical juncture of time where if we did not start working on a war footing to conserve and manage soil and water resources, the very existence of our coming generations will be in danger. It is our sacred duty to hand over the natural resources to future generations in a condition better than we borrowed from our past generations. Being a soil scientist and dealing with management of nitrogen, as you have very well said, because I've been working on management of nitrogen fertilizers in cereals throughout my professional careers, I decided to deliver today's Foundation Day lecture of the Academy on how nitrogen fertilizers are related to soil health and how we can ensure the soil health is not deteriorated due to application of nitrogen fertilizers. It's a big question nowadays because India is the second largest user of fertilizers, nitrogen fertilizers in the world. And as Dr. Kohli raised the question of nano fertilizers, we need to know what's happening in soils and how wisely we should use the nitrogen fertilizers so that not only the production, but we need to keep our soils healthy. And we cannot afford food insecurity for the masses. And even more important is that health of the soil is maintained, rather enhanced, so that our future generations also enjoy the food security. Food security and nitrogen fertilizers came to produce more food, to better yields, higher yields. And we are happy with the kind of yield levels we are having today. But at the same time, now we are more concerned about how long we can work like that with nitrogen fertilizers. So I will try to give you an idea what sort of things nitrogen fertilizers do when we apply them. I would like to analyze how in the coming years or in whether they are deteriorating soil health, or we can continue like that. So the title of my talk today is soil nitrogen, soil health, and fertilizer nitrogen. But before I come to the topic, I would like to share with you a couple of slides on soil, somewhat like Mrida Stuti or Mrida Vandana. So let me shift to this thing, share screen, and then let me see how it works. Yes. Can you see my presentation?
Yes, sir.
Yes, sir. Yes.
That's very good. But it's sometimes too much of technology at this age. Yeah. Anyway, first of all, my congratulations to all of you on this Foundation Day of the Academy. As I said, I also feel honored to be associated with your academy, though as an invited speaker on this Foundation Day. But I wish that I will keep my association with your academy in future as well. Right. So, as I said, the topic is soil nitrogen, soil health, and fertilizer nitrogen. All the three things are very well known to all soil science peoples. I will try to connect all the three things, and then I would like to tell you whether we are on a wrong path or how we can correct our path so that our soils remain healthy and we keep on producing enough food for the masses. Right. So as I said, my first few slides will be about soil, because I feel that we must talk about soil and we must educate our listeners and young students and young scientists that soil is one of the most underappreciated thing on the earth. Rather, it is present everywhere, but we often take it for granted. But you will agree with me that in several fascinating ways, this miraculous substance holds the key to life on earth. All the life on the earth depends on the soil. It does many things. It produces our food, filters and purifies our water, reduces flooding, regulates the atmosphere, and so on. But the most important thing is that more than 99.7% of human food in calorie terms comes from the terrestrial environment, with base is soil. So we must always keep it in mind. I mean, in our religious systems, we say that, well, remember God always. I will say that remember soil always. I mean, only then we can do justice with soil. Well, we have a very limited supply of fertile soil. There are there is 13 billion hectare of land area on the earth. And out of that, only 11% is cropland. 27% under pasture, 32% under forest, and remaining portion is we can't use for all these things. So with this limited supply of soil, when I say soil means soil under cropland or where we can grow something, we need to conserve it not only to conserve, but also ensure that this natural resource remains healthy. The thing which your academy says that we are working with natural resource, and one of the most important natural resources is soil, and it is our sacred duty that we should give technologies to the farmer in such a manner that our soils remain always healthy. If they will remain healthy, they will keep on producing food for the future generations. But if we do something wrong, then our children will be in big problem. So before I go further, I would like to share with you how natural ecosystem and agriculture differ. I want to talk about the fertilizers. In natural ecosystems, nutrients are almost completely recycled. We never had a need to apply any fertilizers in natural ecosystems. But in agriculture, nutrients are taken out in the form of yield or in terms of biomass, and then we have to return those nutrients back to the soil via fertilizers and manures. So that is the big difference between natural system and agriculture. And because in agriculture we need to replenish the nutrients which we have taken out in the form of crop yields and other biomass, so it makes it very different. You can see the two pictures, they very clearly depict how the agriculture ecosystems work as compared to natural ecosystems. Having said this thing, if we look at in a very broad way about how fertilizer nitrogen use in crop production, it seems to support soil health. Why? First is very simple. N lost from the soil by crop harvest is replaced by nitrogen fertilizers. Secondly, fertilizer nitrogen is needed to produce current cereal yield levels of say 3 to 10 per hectare, 10 tons per hectare. And you will agree with me that all our agricultural soils, particularly in South Asia, they do not have capacity to supply enough nitrogen for cereal crops to yield more than 1 to 2 tons, which we always see in our no nitrogen controls. And you will agree with me that if a yield is just 1 ton per hectare of rice or wheat, or 1 ton or 1.5 or 2 tons, we cannot say that the soil is healthy. We have to say it's unhealthy soil because it can't supply enough nutrients to the crop we are growing there. So fertilizer nitrogen, it seems to support soil health in a broad, if you look in a broad manner. I will just give you some data sort of things on how much fertilizer is being used. In 2020, total NPK use was 26 or 27 million tons, of which almost 76% was nitrogen. And if I compare with India, as I said, India is the second largest user of nitrogen fertilizers. China is number 1. And out of, if we total consumption in the world, in 2015, India used 16.3% of total fertilizer nitrogen, whereas China used 29%. But scenario is very much changed by the time 2020. Fertilizer use in India is still increasing. We are now using 18% of the total world global consumption, whereas China has drastically reduced its fertilizer nitrogen consumption. It is using only 22.8%. This tells something that, well, China has started using less fertilizer, whereas India is still continues using more fertilizer. And if you look at the graphs, 2 graphs, the upper graph, which is generally shown that, well, we are producing increasing amount of food grains because we are applying in the pattern of fertilizer use. Nitrogen fertilizer use is very similar to the food grain production. So these two curves, they look very impressive. A lot of people who are in the planning or in political people, they like this type of graph that we are able to produce more food by using more fertilizer, nitrogen, and they have a case for, sometimes they have a case for subsidy and all those things. But if you look at the lower graph, it shows kilogram of food grains per kilogram of fertilizer nitrogen. I mean, for every kilogram of fertilizer nitrogen which we apply, how much is the food grain production? If you look in 1960, it was more than 300. And then we introduced fertilizers, it came down, and now we are almost 20. We are just able to produce 20 kilogram of grains per kilogram of fertilizer nitrogen, where we in 1960s. 1960s is the time when we started using fertilizers. Nitrogen fertilizers, they came in a big way along with the Green Revolution package, because we brought high yielding varieties. High yielding varieties means their requirement of nitrogen was high. Our soils could not support that much those yields or nitrogen uptake by those high yielding varieties, and we have to apply nitrogen fertilizers to supply enough nitrogen so that those high yield levels could be supported. So, but this partial factor productivity of nitrogen, it is very alarming, and I will come to this graph again after we have discussed a couple of more things. Right. So now let's start with what is soil health. Simple definition of soil health is how well the soil does what it is supposed to do. The very first thing we agriculturists do is we practice agriculture with the soil as a base. But besides agriculture, soil also performs various ecosystem services like global climate change regulations, water purification, human health protection, biodiversity conservation, all those things. So whatever things we do with the soil, we define soil health accordingly. So if you are doing with water purification, we have to take some different properties of soils and we define soil health with those. If we are dealing with climate change regulations, we define soil health from that angle. But from the angle of crop production, or the most important soil health indicator is soil organic matter. I mean, everybody knows it, but it is really wonderful thing God has given. Soil organic matter, generally it's very small amount in the soil, but it contains more organic carbon than global vegetation and the atmosphere combined. Whatever carbon is in the atmosphere or in the global vegetation, soil organic matter contains more carbon. You can imagine how much huge thing it is, although contained in the soil in very small amounts. And if that is the condition, if that is the situation, if a soil starts losing organic matter, I mean agricultural soil, its health deteriorates, because soil organic matter is the storehouse of nitrogen. It positively regulates physical, chemical, and biological properties of the soil, and by regulating these properties, it regulates many other, like availability of other nutrients as well. It contains a lot of other nutrients as well, also, but it regulates their availability to crops. So soil organic matter is something which I can say that if we can rather it denotes soil health. I mean, I don't find words to really how soil organic matter is important actually. And for the nitrogen part, it's the most important thing, because all the nitrogen in the soil is contained in soil organic matter. So from soil organic matter, I to come to soil nitrogen, because the three keywords which I have given the title of my talk are soil nitrogen, soil health, and fertilizer nitrogen. The soil nitrogen is the nitrogen which is contained in soil organic matter. So simple. If you look at this schematic diagram, you will see the biggest this biggest box. It denotes soil organic matter and soil nitrogen. And in the center, if you see, there is a soil, mineral, and pool. This is the pool in which nitrogen is present as nitrate or ammonium in soil solution. And from this pool, the plant roots take up nitrogen. So if you look at the size of the arrowheads, I have the thickest arrow is from the nitrogen comes from soil nitrogen. We do apply fertilizer nitrogen. We apply nitrogen in the form of organic manures, crop residues, biological N2 fixation, atmospheric deposition. All they contribute. They will contribute to soil, mineral, and pool. And from this pool, nitrogen is taken up by the crop, or it can be lost as nitrous oxide and ammonia, or lost as leaching also. So, and how much is the soil in the soil? A typical agricultural soil containing 0.1 to 0.15% nitrogen may hold in the soil nitrogen pool about 5,000 kilogram nitrogen per hectare in the top 30 centimeter layer. It looks a very big figure, and but it's true. We are adding say 100 or 200 kilogram of fertilizer nitrogen, but in the soil there is already present thousands of kilogram of nitrogen in the form of organic combinations. But this nitrogen has to get mineralized to go into the soil, mineral, and pool before it can be used by crop plants. So we should always keep it in mind that soil organic pool is a huge amount of nitrogen present in organic combinations in the soil. And as I said in my previous slide, soil organic matter actually represents soil health. And soil N, I will say soil N is basically soil health as far as nitrogen is concerned. Now, most of the time, we always think that, well, we have applied 100 kilogram or 120 kilogram of fertilizer nitrogen to our crop, and when we harvest the crop yield and biomass, we analyze it for nitrogen content, nitrogen content in the straw, nitrogen content in the grain, and we find that we apply something like 120 kilogram nitrogen per hectare, and we have recovered also almost similar amount, because a crop of say 5 tons of wheat or 6 to 7 tons of rice removes around 120 kilogram of nitrogen per hectare. So we applied 120, we recovered 120. So we feel that, well, we are doing a good job, and our soil is happy, our crop is happy, and we are able to produce good yields, and so we can continue like that. But if you look at the data which we get using N15 fertilizers, we find that for any crop, more nitrogen come from the soil rather than fertilizer. So in the first example, which is Daurado Nito et al., you see that average uptake by 6 crop was 147 kilogram nitrogen per hectare. Fertilizer N contributed only 21%, and remain 79% was contributed by the soil. It came from the soil nitrogen, which is contained in soil organic matter. Dr. Lada, he did a very good exercise. He compiled the literature from all over the world, and for rice, wheat, and maize, and he found that, using of course N15 labeled fertilizers, the recovery of fertilizer N was on an average only 44% by the crops. And by the time it was 6th crop, recovery was not more than 50%. So if it is 44% in the very first year, it means 56% came from the soil. very recently, this Yan et al. 2019, he took data from 230 published papers, and he found that nitrogen derived from the soil by crops was 59.8% or 52.6%, depending upon whether we use N15 fertilizer or based on zero fertilizer control studies. Anyway, the amount of nitrogen which is supplied by the soil is always more than 50%. And this, the next gardener and drink water, they try to find out if we are by applying very high fertilizer rates, even then the contribution of soil and pool was to the extent of the last example which I is that this example is taken from a arid region. They applied 85 kilogram of N15 to wheat, and they could find only 33% in the crop, and remaining at the harvest up to in the soil up to 80 centimeter, they could find the remaining fertilizer. Fertilizer has gone nowhere because it was an arid soil, so no leaching was there. Either the fertilizer 33% was taken by the crop, and in the crop, remaining part came from soil nitrogen. So here I want to. This is a thing which many of our young scientists, they just ignore it, that we have applied fertilizer and we have removed our nitrogen. It's almost same. So the thing is, the equation is balanced, and we should not bother anything. But the reality is that soil N is the primary source of N for crops. And as I have said in my previous two slides, soil N actually is soil health, because soil N is part of soil organic matter, and soil organic matter represents soil health. So soil health is very important when we talk of nitrogen nutrition of crops. So having said all these things, we just try to generalize the things. Because half of the N applied in the current year is assimilated by crops, where does the remaining half goes? Say we, as a gross approximation, 50% is taken. 50% is taken up by the crops. Where does the remaining 50% of the fertilizer N goes? A big portion of the remaining 50% is incorporated in the soil organic matter. That is the thing to be, that is the most important thing. We apply 100 kilogram of nitrogen to the soil or to a crop. 50% is taken up by the crop in that current year. The remaining 50% N is either it gets incorporated into the soil organic matter and it persists there for decades. There are so many papers on that. And the nitrogen which is taken up by the crop, that is coming from the soil nitrogen or soil organic matter, but at the same time fertilizer nitrogen which we are applying, a big part of it is going into the soil organic matter. So what happens is that 50%, say 50% is taken up by the crop, and after the remaining 50%, say 30% goes back into the soil organic matter, 20%, or it all depends on soil properties or the climate or environment, it can be lost. To say that 50% is lost is wrong. And then another thing which comes out of it is that every year when we are applying fertilizer year after year, the portion of the fertilizer nitrogen which goes back to the soil nitrogen or to the organic matter, it remains there for decades. And this is the nitrogen which we have applied previously in previous years. It then in subsequent years it becomes available for the crop. So this cycle is going on like that. So implications for this thing here are, if we stop applying adequate amount of fertilizer nitrogen to the crops, what will happen? The nitrogen which is going to the soil and pool will be reduced, and then when we keep on growing the crops, the soil and pool will be gradually depleted. That will lead to decline of soil health and crop yields will start declining because, as I said, more nitrogen comes from the soil. And now Dr. Anshuman Kohli asked me to comment on nano urea. To my point, if we apply nano urea, just 40 or 400 gram of nitrogen instead of one bag of urea of 45 kilogram, if we are applying nano urea this first year, the yields may not decline. You will get good yields. Second year, third year, fourth year, yield will start declining because the soil and pool is not getting replenished, because we are not applying enough nitrogen to keep the soil and pool or to keep soil healthy. So as I said earlier, only portion of the annual fertilizer N input that exceeds the amount of N either removed by the harvested crop, and that becomes a part of the soil and pool. So whatever is left, only that is vulnerable to losses to the environment, not that all the 50% is lost. So we have to be very careful in terms of how to analyze the situation with respect to nitrogen fertilizer. It's not simple arithmetic. It's not simple addition and subtraction. It is a very complicated thing, and sometimes it becomes frustrating also. But the reality is this, that we have to apply nitrogen fertilizers to keep our soils healthy. Otherwise, with the time, if we start applying less amount of nitrogen to the soil and keep growing the high yielding varieties or the crops which require a lot of nitrogen, gradually soil and pool will be depleted, and then the effect of the soil health deterioration will be visible in crops. And same thing will happen with nano urea with time. And that's the main criticism of nano urea, that unless we need to apply enough nitrogen to keep our soils healthy and keep our soil and pool up to the level. This was one thing. Second thing is, in agriculture system, soil health is also reflected in the ability of soil to respond to agricultural interventions. If a soil is healthy, it can respond very well to the interventions. And what are interventions? The most important intervention is tillage. Since the evolution of modern agriculture, tillage was the first intervention which was there into agricultural soils. Tillage leads to loss of soil organic matter. I mean, it's very well known now. The second important intervention was irrigation. We knew that water is required and for growing bumper crops, and we devised ways to irrigate our soils. The third big intervention are fertilizers. Large-scale introduction fertilizers came with Green Revolution, and being chemicals, they can potentially alter the natural functioning of the soils. And the sad part is that many farmers tend to apply fertilizer even more than what we recommend. They want to avoid the risk of yield loss. And unfortunately, because fertilizers in our countries and in many developing countries, they are highly subsidized. But India is very famous for that. And because of their high subsidy, the nitrogen fertilizers are very cheap if we look into the total budget of the farmer in terms of the inputs. And the farmer says that, well, let there be no deficiency of nitrogen. Let me put 1 or 2 more bags per hectare or per acre. So this is the worst part, and so that means that we are applying. This is an intervention which we have to look into whether application of fertilizers is doing any harm in terms of soil health. The first part is that I have already explained that nitrogen is required to maintain soil health, but at the same time we have to look fertilizer from the point of view of an intervention, whether it's doing any harm to the soil. So let's see what happens when we apply fertilizer. What happens on soil organic matter when we apply fertilizer. When we apply fertilizer, as per to produce optimum yield levels, or when we apply the optimum level of fertilizer, it leads to increased total organic matter inputs, because net primary productivity minus harvested yield, it remains in the soil and it leads to buildup of soil organic matter. Of course, nitrogen part is there, which I've explained already. Then if we apply fertilizers up to the optimum levels, the reduced microbial activity due to acidity generated during ammonium oxidation of nitrogen fertilizers, they may lead to reduced soil organic matter decomposition, which also leads to soil organic matter buildup, or it's not reduced. And in certain ecosystems, the fertilizer nitrogen adversely affects the activity of lignin degrading microorganisms, which also favors organic matter accumulation in the soil. So if we are applying fertilizer as per the requirement of the crop in optimum levels, it leads to soil organic matter buildup. But what happens if we apply fertilizer nitrogen in doses more than those leading to optimum yields? Excessive application of fertilizer, which I have already indicated that many farmers in countries where fertilizers are available on subsidy, or even otherwise, if a farmer can afford to buy more nitrogen fertilizers, they have a tendency to apply more nitrogen fertilizer to their crops. If that is the situation, under that, what happens is that it leads to accumulation of residual inorganic iron, because crop will take up only that much nitrogen which it needs. The yield levels won't increase after the optimum yield level is achieved. And that nitrogen, inorganic nitrogen, which stays in the soil, it stimulates mineralization of soil organic matter, and it results in its net loss. And if there's more fertilizer nitrogen we have applied, it reduces the CN ratio of crop residues, and that also accelerates their decay. So the thing is that if we are applying fertilizer at optimum levels, it's all fine. No loss of soil organic matter, no deterioration of soil health. But if we are applying more nitrogen fertilizer, more nitrogen, it can lead to deterioration of soil health in terms of reduced soil organic matter. So the two aspects. One is the nitrogen enrichment of soil organic matter, and second is the quantity of soil organic matter itself, how it is affected by fertilizer nitrogen. So I will just sum up this, what I have said, the last point. This is the way it works. If we apply, this is the middle, this is the optimum level of fertilizer nitrogen, number 3. Below this nitrogen level, yields will keep on increasing. Nitrogen use efficiency, of course, it keeps on decreasing, but inorganic nitrogen levels are very low. But moment we apply more fertilizer than the optimum levels, yields won't increase. Nitrogen use efficiency will be almost negligible, but the soil organic nitrogen, this line, that will shoot up like anything, and it leads to destruction of soil organic matter. Now, if soil organic matter in this is lost, it automatically leads to deterioration of soil health. So now I will look at this first graph is okay, more fertilizer, more yield is okay. Now if you look at partial factor productivity of fertilizer nitrogen, why the curve is like that? It was this kilogram of grains per kilogram of fertilizer nitrogen was very high in the beginning. At that time, the nitrogen in our soil was pretty good in terms of the yields which we are producing with the traditional varieties. But moment we started applying more and more fertilizer, the nitrogen content in the soil, the nitrogen content in soil organic matter, that started. And that was the reason why now we need to apply much more fertilizer to get the same yield.
All of you, please mute yourself. Everybody, please mute yourself. Except Dr. Bijay Singh, please mute yourself.
Excuse me.
Dr. Arora, please mute others except Dr. Bijay Singh.
Is it okay? Are you able to listen me?
Just a minute, sir. There is some disturbance. Dr. Arora, could you please mute everybody else? Pala Chandra, please mute yourself.
कर दिया,
Yeah.
कर दिया.
Okay. So if we look at this partial factor productivity graph, the sharp decline with it is because the quality of soil organic matter or the soil organic matter itself, it has started declining, and that's the reason we have to apply much higher amount of fertilizer nitrogen to produce same yields now. I will explain later on in a better way. So there are a couple of reasons for nitrogen use efficiency decline because of the shape of the response curve. As we move on the shape on the response curve, you will see that at higher fertilizer and rates, the yield won't increase, and that's the reason that as farmers move yield levels higher along this fixed end response curve, a decrease in NGU was expected. So initially, the decline in NGU was because of adoption of fertilizers, but now in the last 2-3 decades, it is due to loss of soil organic matter or soil health decline, excess application of fertilizer nitrogen, and inadequate fertilizer and management. There are 3 things which I've listed here: loss of soil organic matter, which is equivalent to soil health decline, excess application of N, and inadequate fertilizer nitrogen management. So these are the 3 factors which are driving with the drivers for this kind of partial factor productivity graph. So let me look. So I just give you an example. Farmers said that we put in over 200 kilogram of urea per hectare in our fields this time, but the yields have been far lower than last year. Urea has completely messed up our lives. That's the thing, because the farmer was applying too much nitrogen to his fields for several years, and in that process, he has reduced the quality of soil organic matter as well as organic matter itself. And now the situation is that to get the same yields, he has to apply much higher fertilizer and doses to get the same yields. And this is what's happening in our country as well. The very first graph, the first graph, which shows that cereal grain production is going very parallel to the fertilizer and use, and this is because we have to apply more and more fertilizer nitrogen to get higher yields. So this is very alarming situation, and we need to really work on. Now I give you some examples from our long-term experiments. These are long-term experiments on rice field experiments in our IGP. If you look, these are the location, study period, and fertilizer nitrogen, which is applied every year to the 2 crops, rice and wheat. It is almost 180 to 240 kilogram nitrogen per hectare. This is the depth. And look at the change in soil organic carbon. You see, very small change, or change is positive. I mean, by applying, because we apply fertilizers as per the recommendation, the change is always positive. I mean, they have these soils, the fertilizers, when we applied as per the recommendation, they led to increase in total soil organic carbon or soil organic matter. Barring one or these in Pantnagar or the values are Kalyani, they're negative because they started with the soils which were virgin soils. Otherwise, the soils which are under cultivation for a long period already, by applying fertilizers, we always lead to better soil health. But fertilizers have to be applied as per the need of the crop, not an excessive amount. As I told you in the beginning, also when I was talking about the interventions, cultivation or tillage is something which is a very big culprit in terms of reducing soil organic matter and soil health. So in this example where I have shown you a positive change in soil organic carbon because of applying fertilizers, you will imagine that, well, this change is over and above the negative change which have been created by tillage. So the change is much higher. It has taken care of tillage as well. So that means if we are applying fertilizers as per requirement of the crop, that will lead to buildup of soil health and soil organic carbon. But just a couple of more. If you look at the control plots in these long-term experiments where we didn't apply any fertilizer, you will see that soil organic carbon, there's a reduction always. It changes almost everywhere. It's negative. That shows that we didn't apply any fertilizer, but our plots were cultivated or tilled, and because of that, there was a deterioration in soil organic carbon or soil organic matter content. That shows that fertilizer nitrogen, as such, if we are applying as per need of the crop, we can continue using them to produce high yields without any damage to soil health. But if we are applying high levels of fertilizer nitrogen, which many farmers do, then we are definitely damaging the soil health and the soil organic matter levels in the soil. So here I show you some meta-analysis. I could find 4 of them. The number of experiments, 6,400 and 420 and 4,600 different crops, and they show that by applying fertilizers, the increase in soil organic matter over the unfertilized control was something like 12%, 13%, 8 or 10 or 13% in all type of ecosystems, whether they are lowland rice or non-lowland rice or from Europe or from all over the world. By applying fertilizer, we definitely help the soil in terms of getting it more healthy. But we have to be very careful that we are not applying fertilizers more than what is required. Otherwise, it can be very damaging experience. And once, as I've explained to you, once soil health starts going down because of excess fertilizers, we have to apply more and more fertilizer to get the same yields, and in that process we further damage the soil health. So I give you very simple conclusions. Neither mineral fertilizers nor organic manures destroy the soil health when applied at agronomically correct rates. That's very, very important thing, which our extension staff, our planners, they must adhere to it in a very strict way, that we must apply nitrogen fertilizers at agronomically correct rates or as per need of the crop. The best way is to use site-specific nitrogen management, because when we go for site-specific, then we apply field-specific doses of fertilizer, and they are always as per the need of the crop. Whatever nitrogen soil can supply, we must match it with our fertilizer. But second thing is, excessive or indiscriminate use of nitrogen fertilizers can be detrimental to soil health, as well as can cause serious environmental damages. So the better soil health can only be ensured through efficient management of nitrogen fertilizers. And if decline in soil organic matter, the most important indicator of soil health, following application of synthetic fertilizer nitrogen would have been a general phenomena, it almost certainly would have a major consequence for food production, as it would have resulted in a spiral of decline in soil functioning and crop productivity. Fortunately, it is not like there. We we are damaging soil health only when we apply, when we use nitrogen fertilizers indiscriminately or at very high levels. So the carry-on messages are: first thing, the mental model that fertilizer nitrogen acts as a replacement of nitrogen minerals from the soil organic matter needs to be revisited. Our young scientists, they must keep it in mind that it's not simple arithmetic addition and subtraction, that whatever nitrogen is available from the soil and then we have to add the remaining through fertilizer. It works in a different way. Fertilizer nitrogen, as I have explained already, fertilizer nitrogen which we apply, a part of it is taken by the crop, remaining a big part goes into the soil organic matter, which in subsequent years come back to to nourish our crops. The second carry-on message is application of more than optimum fertilizer and rates deteriorate soil health by eroding soil organic matter. And fertilizer and management needs to evolve. And this is the most important message which I want to convey. We need to work on fertilizer and management, considering the huge role of soil and in the nitrogen nutrition of crops, and ensure that health of the soil is, in terms of sustaining supply of soil, and is maintained, if not enhanced. And in very simple language, soil health and efficient nitrogen use go hand in hand. More efficient we are in managing nitrogen fertilizers, the healthier our soil will become, and vice versa. And before I finish, I want to show you this beautiful graph with three colors, red, blue, and black dots. They show India, North America, and the world. The fertilizer use not in total quantity, but kilogram nitrogen per hectare. In total quantity, in terms of total quantity, as I told you, China is number 1, India is number 2. But now let's see fertilizer use per nitrogen per hectare. You will see that we, up to 1995, we were the least, the fertilizer end use was the least in India. Even world average was higher. Of course, North America was using much higher amount of fertilizer nitrogen per hectare. But after 1995, those two, North America and world, their nitrogen use is not increasing or almost stabilized. But in India, we are still going like anything. And this is very dangerous trend, I tell you, because if we keep on applying more and more and more and fertilizer to our soils, we are inviting deterioration of soil health. And if that will be, if that is there, we will have to apply even more than that fertilizer to produce same amount of yields. So this is, we must keep it in mind. Otherwise, the things will be out of hand. And last is this thing. I hope I tried to make the things clear, but if still, if there are any clarifications you need, I'd like to discuss with you.
Thank you, sir. Thank you for an elaborate and a very thought-provoking presentation. I suppose those students who have missed this are unfortunate. This is something which every student should have attended, and you see, the things that you have talked are very basic, but often not covered in the usual syllabus. Because when we emphasize, while we are teaching nitrogen, we do not emphasize on these exact things which you have dealt with. Although most of us have an idea that this should be the way out, how we are managing nitrogen, this should be the way nitrogen should be managed. But then your presentation has been very philosophical, very basic, as well as very applied. So thank you, sir, for all this.
For me also,
yeah, there are some questions in the chat box also, sir. I would like, if you can get to read them, or I can read them for you. You can selectively choose to answer them.
Let me go back. Oh, how to really, yeah. Oh,
Can I ask? Hello.
yeah, yeah, that's better. That's better, I think.
Nowadays in our country, this natural farming or ethnic farming is because of the government they are propagating in the
Yeah.
very large scale, and they advise to the institute to do the work mainly the basically to the this natural farming and organic farming. What is your view?
Well, it's so simple. Whatever I have said in this talk, we need to maintain a good soil nitrogen pool. And first thing is that by following natural farming or organic farming sort of thing, we will not be able to achieve those high yield levels, because the total amount of nitrogen which will be available to the crops will be much less, because we are whatever nitrogen is available from the soil, we are supplementing it with the fertilizer nitrogen. And as I explained it very clearly, that fertilizer nitrogen doesn't simply, it's not addition, it's not a simple addition, but fertilizer nitrogen also goes into the soil organic matter, and which ultimately, which in next subsequent years it comes back. If we follow organic farming or natural farming for a couple of years, say 5 or 10 years, then we will start getting even lower yields. Up till now, when we start using natural farming or organic farming, we will be able to get fairly good yields in the beginning, but with time, it will not be possible to sustain those high yield levels without applying fertilizer. Fertilizer nitrogen has to be applied, but in a way that it doesn't exceed the crop requirement. The blunder which we are doing is that we are giving a lot of subsidy to the farmers. The fertilizer nitrogen is very, very cheap. Urea is very cheap, and farmers are using urea like anything, and they are ignorant about that, think that they are damaging the soil health, damaging the soil organic matter. And that is the reason that with every passing year, they have to apply even more urea to get the same yields. And this applies to the natural farming in a different way, that we are depleting the soil nitrogen with time, and we are not replenishing it. And if we are not replenishing it, after a couple of years, after five years, depending on what kind of soil organic matter we have in a particular soil, then we will start feeling the heat in terms of reduced yields. So going for organic farming or natural farming without giving a thought about in the long-term basis, it will not be good for the country. This is my feeling.
Okay, thank you very much.
Thank you. What are the more? Anji.
Basically, the role of biofertilizers, biostimulants, and many of the growth enhancers, especially the microbially mediated these formulations, helps in nitrogen mineralization, helps in nitrogen use efficiency in one sense. And we have seen that in our experiments also, the performance was like that, and we can reduce the application of nitrogen to a smaller level. Do you think for a long-term basis, for improving nitrogen efficiency on the one hand, and also reducing the use of nitrogen fertilizers, especially urea, can this be a good option?
Well, as I have explained, Aman, it is the same thing like applying nano urea or the biofertilizers. We have to replenish nitrogen which our soil has lost. I mean, we have to think on a long-term basis, not for 1 or 2 or 3 years. For first 2-3 years, it will be okay. I mean, your biofertilizers or other things, they will work. If they will help in mineralizing nitrogen, That means more soil nitrogen is coming. Already soil nitrogen our crops are taking more nitrogen from the soil, and applying biofertilizers will further enhance the contribution of soil nitrogen. And that means that the nitrogen in our soil organic matter or soil nitrogen is depleting. So we have to replenish it. Otherwise, I'm talking on a long-term basis, not on 1 or 2 years. Otherwise, the thing will be going out of our hand, actually. And unfortunately, most of the studies which are done with like particularly nanofertilizers or biofertilizers or other things, they are very short-term studies. And short-term studies, and then we jump to the conclusion that this is okay, and we are able to save fertilizers. That's not the way. If you think that my message is that don't apply too much fertilizer. Apply fertilizers as per need of the crop. Moment we start applying more fertilizer, the damage is being done. And you can use all those biofertilizer, everything, but always keep in mind that we need to replenish the whatever amount we are removing. In nanofertilizer also, as I said, if we are removing 120 kilogram of nitrogen per hectare from the soil in one crop, 2 crops, so from where the nitrogen will come in subsequent years? By applying 400 gram of nitrogen in a 1 bottle of nano urea, how long you will be able to, from where you will produce nitrogen, which crop will take in subsequent years? Same applies to these biofertilizers.
But so these biofertilizers some of these have the potential for atmospheric nitrogen fixation also.
That's good. My submission is that we need nitrogen from somewhere. Understand it. I don't say that from where. Our soils are receiving nitrogen from atmospheric nitrogen deposition also. Continuously they are coming. Our soils are receiving nitrogen from the biological nitrogen fixation also. If we can arrange nitrogen supply, whatever we have lost, then it's okay. We will get sustainable high yields. But if we forget about replenishment, then the problem will start after some years.
Sir, about neem coated urea and poly coated urea. These days we are talking much about these for slow release or something like that. But ultimately, coating with the neem oil or with the synthetic polymers, there is interference in terms of microbial activity in soil, and which really means affect the hydrolysis, or we can say the mineralization or the nitrification. So these processes are reduced. So can this be a good option?
First thing is that all the urea which is being sold in India nowadays, neem coated urea, is yellow in color now. Yes. So neem coated urea idea was to reduce the nitrification process so that it remains as ammonium for a long time. I mean, we retard the process of conversion of ammonium to nitrate so that it is not lost as nitrate. So that part is okay. I mean, neem oil is doing its job, but we don't have situations everywhere like that. I mean, we don't need neem coated urea for all the situations. This is a blanket thing which you have done in India, that we apply. We have given direction to all the fertilizer, whether urea is imported from other countries. Even then, we have arranged to apply neem on those urea. It's an additional cost, but it is not. It is needed on a very small amount of small area regions actually. Wherever there is a problem of nitrate leaching, soils are sandy or very coarse in texture, where the leaching part is there. Otherwise, and then the nitrification and nitrogen properties, they are affected by pH also. Not all the soils, not under all the soil conditions they will work. And so the neem coated urea, it is okay. I mean, if our government is saying that, well, we are ready to provide you neem oil coated urea, So it's fine, but it has no harm actually. If the cost is being charged to the farmers, like they have reduced the size of the bag from 50 to 45 kg now.
Yes.
So the 5 kg, that is actually being charged to the farmer indirectly. That is pinching. Coming to your coated ureas, polycoated ureas, or they are good materials. They reduce the solubility or the release of urea from the granules. They are slow release fertilizer, but we should be able to use them only if they are cost effective. By coating the urea with some material, maybe sulfur, or maybe I was reading just 2 days back, there was a so-called gold urea has been introduced, which is a sulfur-coated urea actually, because its color changes, it becomes yellow. So they have given its name a gold urea. I don't know which fertilizer company has introduced it. So it's a sulfur-coated urea is a wonderful material in terms of increasing the efficiency of fertilizer, but is it economical? That is the point. The process of the material which we use for coating and then the process for coating, they both add to the cost. So if in future we are able to produce these coated materials at a reasonable prices, then they are wonderful materials. But at the moment, I think they are very expensive compared to the ordinary urea or neem coated urea. Neem coated urea is not a slow release urea. It is only a nitrogen inhibitor. Neem oil. It is not, no coating is there. It's not a slow release material.
Thank you.
Anything? Anybody else? I can't see the questions. Oh, there are messages.
The questions in the chat box, sir. I'll read it for you.
Oh, I see.
Sir, good morning.
Oh, I see. I now.
How
now
nitrogenous fertilizers is going to supplement soil and meeting crop demands. Then the role of microbial inoculants or biofertilizers. And do neem coated or polycoated N fertilizer really benefit for end users? I think you have answered these in the discussion that we just had. Then Dr. Parikh has asked, what should be N management strategies for arid ecosystem for sustainable productivity of crops? But I would like to add something to this, that when we are saying that we are introducing nano urea or other coated ureas, that the basic philosophy with the government of India is to reduce the subsidy burden. Now, while answering this question for the arid ecosystem, I would like you to keep in mind this policy of the government of India, that it is promoting, I feel that it is promoting nano urea just for the sake of reducing the subsidy burden. Because the scientific fraternity has
I don't know whether, excuse me, I don't know whether you are following some discussions which are going on. Only last week, a very critical paper has appeared about nano urea.
Yes, sir, in plant and soil. Yes, sir.
Yeah, plant and soil. You might have seen, and it is getting very big ripples in the whole ICR and everywhere actually. And it was known 2 years back when nano urea was introduced.
Yes.
But nobody listened to it. All the planners who were behind the popularizing it, they didn't bother about the science involved in it. As I said, nano urea may be more efficient because we apply on a foliage actually.
Yes.
We can maintain or we can produce equivalent yields for a year or 2 or 3, but not always with nano urea. That's the main problem. As I've explained to you, I intentionally gave this talk today here. I spent last week a moment you told me this thing, that I must tell the truth actually what is happening in the soil. We should not bother about that. This fertilizer is good. That fertilizer. If we understand the things which are actually happening in the soil, we can easily analyze whether this material is going to work for us or not. We have to think in a long-term basis. We cannot think only for 1 or 2 or 3 years. If we are deteriorating soil health, if we are deteriorating nitrogen in our soil nitrogen, then we'll be in real big problem. We have to apply more and more fertilizer with passage and to produce the same yields. that situation, if it come, it will be very dangerous actually for the country to produce enough food for everybody. And then there will be that why scientists were not aware of all this. We are telling that you have to replenish. Simple, it's very simple. I mean, if we are removing something from the soil,
So we have to replenish.
we have to give it back.
Yes.
But there's a
In the arid
way to do
ecosystem, sir, in the arid ecosystems, when water availability might be a constraint at the time of top dressing.
that. Yeah.
So at that time, if we can go for foliar application, I mean, it's not going to affect the soil as such.
Yeah, this okay. Foliar application is you cannot depend exclusively on foliar application.
Yes.
Sir, I have one
Foliar
question.
application is not bad thing. I mean, when nitrogen is needed by the crop in a very immediate way, we should apply foliar application. And nano urea does it. Nano urea does this job very well. Yeah.
I have one question that worst thing is that the promoters of nano urea are spreading the things like that. It can replace the basal application of nitrogen.
Yeah, this is wrong.
From the scientific fraternity, they are popularizing the nano urea, and now they are popularizing that it can replace the basal application. How it will be possible?
No, it's not possible at all. So simple. Nano urea will, I explaining it again and again that nano urea for 1 or 2 years you will be deceived by that. Well, crop yields we are able to maintain the crop yields because our soils are still able to supply enough nitrogen. But how long? 1, 2, 3 years?
Yes, yes.
Then you will start feeling the effect of reduced soil nitrogen.
You have to maintain the pool of nitrogen, na?
It's so simple.
Thank you, sir.
This pool is not created by us. This pool has been created by the God for us. As I explained, nitrogen, soil is such a wonderful material. Soil organic matter is even wonderful thing which God has put in the soil. God has planned to feed all of us. I mean, if we have, but we are damaging the things which are created by the God by our foolish things.
We have to maintain
Yes,
this.
I
Yes,
have.
sir.
Hello, sir. Good
Dr.
morning.
Gurumurthy, please.
Good
Haan ji,
morning, sir.
bataiye ji. Good morning.
So very nice to hear you, Dr. Bijay, sir. I just remember long back I had a talk by K.V. Raman, organic matter is a mainstay of nitrogen in soil. So maybe 30 years back. So he was really given inputs and you all really replicated them with your all the evidences. So that was really great, sir. What is my observations here? In semi-arid conditions, most of the Indian conditions, the soil is subjected for drying for many times within the cropping season. And that time the nitrogen management again and organic matter management as well as nitrogen management is a very difficult task. Then the second one is the biological nitrogen fixation, which is non-symbiotic in soil, both in soil as well as in water. So that I think is being supplemented in a better way. And then the third one is the nano nitrogen. I think many people are speaking also. It may be a supplement. It cannot be a substitute the nitrogen because they are climbing 1,000 times high. Because after all, it is a 26 grams. It is there. It is presenting into the 500 ml bottle. And we are applying per acre 46 kg, even 50% to take use efficiency, 23 kg directly plant is absorbing for us. So I think these critical features, your presentation is apt. I think it requires so much introspection. What is to be done, particularly the nitrogen is not only for crop, but it is a protein supplement through the crop or forays or whatever it may be. So this is a really good, nice to hear you. I wanted to throw some light on the semi-arid environment. How does nitrogen can be managed under a persistent drying conditions? Please, sir.
Well, the thing is, I mean, what I told you was a very general thing. I mean, it applicable to all type of soils, but we have to modify our approach under different climatic conditions or different kind of soils, depending upon how much moisture is available, how much temperatures are there actually. I mean, moisture and temperature are the two most important things which make how much N will be released from the soil organic matter or how much organic matter will be there in the soil. our soils, most of our soils, because of high temperatures in the Indian subcontinent, they don't have enough. They don't have much higher organic matter content. So under those conditions, we will have to, say we are growing a crop of rice. So rice is a very different crop. We have submerged conditions. The things will be altogether different there then. So I didn't talk anything specific to a crop. I'm simply saying that, well, you must respect the soil organic matter which is contained in our soils. Don't treat it harshly. Otherwise it will treat you very harshly. It will be a big problem.
That was the real thing.
So depending upon the region or climatic conditions in which a person is working, if a working is in North India, South India, or in Rajasthan, arid conditions, they will have to devise the things or manage fertilizers accordingly so that the crop can take the total amount of nitrogen which is required, but at the same time, we are not damaging the soil organic matter content or soil nitrogen in the soil. So we will have
Yes,
to.
sir. What you told is 100% right. We need to harness the technologies to improve the soil organic matter, and use of the fertilizer nitrogen is a must.
So simple. We cannot afford to produce less. We cannot afford to damage our soils.
Yes, sir. Thank you. Thank you very much, sir. Great. Thank you, sir.
Yeah. So then in the chat box, we have another question. Whether unexplored sources like lightning, unintended natural organic matter addition, and other unknown sources would be able to make up for the N addition shortfall associated with the use of nanourea. I think this has also been.
I have replied it in a very This is we want nitrogen in the soil, enough nitrogen in the soil, from anywhere it comes. Whether it comes from biological nitrogen friction, whether it comes from nitrogen deposition, whether it comes from from anywhere. If we are not able to keep enough nitrogen in the soil, it is going to tell upon its health, not only its health, but upon the yields as well. So simple.
And another question is, sir, a factual question, maybe like you like to comment on it. Which is the cheapest source of fertilizer? Nano fertilizer or a commercial N fertilizer?
It's urea. So simple.
Okay.
Cheapest. You have I don't say it is the best, but it's the cheapest.
That's the cheapest.
Nano, I don't consider nano as a fertilizer, to be very frank. I'm totally to me it's a hoax.
Yes, sir. Then somebody wants to know what should be the nitrogen management practice in case of natural farming to replenish soil and pool?
Well, in natural farming also, if we are able to supply enough nitrogen in the form of organic manures, biological nitrogen fixation, things will work.
Okay.
No worries. We don't specify any source of nitrogen, because fertilizer nitrogen is the commercial product which is available in plenty. We are producing in plenty. It's available to the farmers, subsidized. So use it, but in a proper way. Don't use it indiscriminately. I simply say. And in case of natural farming also, if you can manage nitrogen from different sources, it's all nice. Even natural farming will be producing, I won't say very high yields, but good yields.
Yes. Yeah, thank you, sir. In fact, sir, it's now past the time that we have scheduled for your interaction also. But maybe like we can take one or two questions if anybody still has to.
Yeah, most welcome. Now although it's midnight here now, but I'm fully awake now. No worries.
Sir, I am having one question, sir.
Hanji.
Good morning, sir.
Very good morning, ji.
Sir, I am trying to simulate the total nitrogen loss and total phosphorus loss from the Satluj catchment of the Punjab area using the SWAT model. So we are having the gauging station at the Ropar and one at the Pillor. So the recommended dose by the PAU, and if I will take the recommended dose by the PAU, for the different crops.
Yeah.
So my model is not simulating the proper set. So I was thinking, I was discussing with some of the professors. They were saying you take the farmer practices. So in the case of farmer practice, as they are using double whatever the recommended by the PAU, the farmers. I got only few papers on rice and wheat. So in that case, sir, we are having the two scenarios. In my catchment, the most of Satluj catchment, the Kandi region is coming, where they are applying as fertilizer. And the lower part of the my study area, they are applying the high fertilizer. So how I can take that farmer practice dose to simulate this impact? Actually, I have done this analysis, but one I was writing that, so I am facing the difficulty.
The thing is, the farmer who is applying high dose of fertilizer, they have been applying high dose of fertilizers for last many years actually. You understand what point?
Yes, yes.
Farmer who is applying high amount of fertilizer, he is applying higher doses of fertilizer for last several years. It's
Yes,
not
sir.
that they have started only now. This is the damage they have done to their soil, and now they cannot stop applying more fertilizers. It's just like nasha. Urea, so simple. Addiction. This is nothing more. We are making our soils addicted. By
Yes, sir.
because-
Yes, sir.
because
When we will look at the data of at the Buddha Nala and the Philor, so their total nitrogen concentration in the river water is too high, and even same for the phosphorus. So
Yeah.
that trying to simulate the which water is how much it's contributing more in the case of river polluting the river water.
I didn't follow. I mean, you didn't follow. What is your last part of the question? I'm talking when you talk about water.
My question that also I am trying to simulate the hot spots watersheds within the Punjab.
Yeah, that's good. I mean, why I have compiled a very nice paper last year about nitrogen fertilizer, nitrogen pollution sort of thing. If you wish, I can send you that. You can write to my email. I mean, Anshuman has my email, and then I can send you my papers on water pollution as it is related with the fertilizers. Maybe it's helpful to you, but this is very sure that if you are applying more and more fertilizer, more and more out of fertilizers getting out of the soil plant system, and it will ultimately reach the groundwater or surface water, whatever you are dealing with. And nitrogen levels are certainly increasing in our waters. And I don't know. I mean, the answer really lies in that we should start using fertilizers in a rational way. If we are not able to do that, we will be in problem in terms of producing high yield, but we will also be having polluted waters as well. I can give you a very simple. In my PhD, which I did in 1976, the problem of my research was contribution of fertilizers to groundwater pollution. In those times, in 1970s, I was asked to explore the possibility of fertilizers polluting groundwaters. And at that time, the levels of nitrate nitrogen in groundwater was only 0.2 milligram per hectare, or 0.2 milligram per liter. After 10 years, the level was 2 milligram per liter, and now it is more than 5. And moment it exceeds 10, the waters will be good for our soils because they are supplying nitrogen, but they will not be fit for our drinking. So another problem will start then. Till the levels are less than 10 milligram nitrate nitrogen per liter, it's okay. We can drink them, but moment after that, they will not be fit for drinking. But they will be good for applying to the fields. Our crops will be happy with a lot of nitrogen. It's a very complicated question. I mean, in PAU, I mean, the control yields which we used to get in 70s, we cannot get those control yields. Now the control yields, no N plots, they are yielding much higher because they are being applied. The water which is being applied to the control yields is containing a lot of nitrogen. We are not applying fertilizer, but nitrogen is going into those because of the water contains nitrogen. So if we start going to all these things, then the things become much more complicated. But for today, my message is that don't apply fertilizers more than what is required. So simple. If you can do it, we can save our soils, we can produce high yields for in future as well. Otherwise, it's like addiction. Urea, you have to apply more and more and more urea to produce same yields.
Thank you, sir. Thank you to Navneet also. Sir,
Sorry, sir,
I don't
I
think
got
if,
disconnected.
sir, I would like to just mention here that Mr. Navneet Sharma became associated with us and with this academy around 2019 only at the time of its inception. And it was then that he, probably because of his association with Dr. Sanjay Arora and this association, that he went for his PhD in Ludhiana.
Oh,
So
I see.
probably at the beginning we were discussing how this academy initiated with PAU association, and then now there are people who are going to PAU because of our interactions at this stage.
Yeah, well, that's very
Thank
good.
you very much, Navneet, for this.
Yeah, well, thank you. I also enjoyed talking with you people, and it made me feel that, well, I am still a scientist.
In fact, when you had conceded to our request and suggested this topic, soil health and fertilizer, and I and Dr. Arora were even discussing whether we should request you for slight modification of the topic so that it suits more like a foundation day lecture. But then we decided to keep it as such, and we are lucky that we kept it as such, because you have so wonderfully justified this to make it so basic and applied at the same time. I mean, it is so thought-provoking that we are so grateful to you for all this.
Thank you very much.
Thank you
I
very
also
much,
enjoyed.
sir. Yeah,
Thank
and
you very
now,
much for. Thank you very. And now I won't be able to join you for a cup of tea.
Sir,
we
actually,
don't even have that.
Before that, sir, I means Dr. D.K. Sharma remarks is to be taken
I
on.
request Dr. D.K. Sharma for his chairman's remarks.
Sure.
Okay, thank you very much. This topic is more relevant to the present day because of the pollution and soil health point of view. And I explain this outcome of this talk. Dr. Singh introductory remarks on sustained management of natural resources, how nitrogen fertilizer will help to maintain and improve the soil health and environmental pollution. And he also mentioned that about 76% of nitrogen fertilizer was used only out of total fertilizer consumption. 76% nitrogen was used. It is about 27 million ton of total NPK used in 2020, and nitrogen is used 20 million tons. Then he also mentioned that the partial factor productivity is decreasing day by day, and he also explained the reasons. And he pointed out that the nitrogen balanced fertilizer, and also he reviewed several references, not only the India but the foreign countries also, especially the Canada. And fertilizer, this used 21%, and the contribution of the soil organic carbon contribution is 79%. And he mentioned that low nitrogen use efficiency during last 2 or 3 decades, due to low recovery of nitrogen fertilizer and also more losses of nitrogen fertilizer. He also mentioned that in Indo-Gangetic plains, then farmers are doing rice wheat cropping system last 20 years. He mentioned in the reference. And the farmers usually apply 180 to 200 kg of nitrogen fertilizer. And this also will improve the soil organic carbon. It is a good findings because pupils and also the some policy makers, they are saying that the nitrogen and fertilizer use decrease the soil organic carbon, but it is not true. But when the control plot is there and no fertilizer was applied, then this soil organic carbon is reduced. And he also mentioned the take-home messages. First one, then fertilizer nitrogen as a important factor to increase the yield and also the soil organic carbon. And the optimum fertilizer is also very much essential. If the fertilizer will use excess amount, then it will create the problem. Then third, management of nitrogen fertilizer practices are very much important for soil health and maintaining crop improvement. Now, one of the important things I have watching in the Dr. Singh presentation, because it is learned to our young scientists and students. And I am requesting the scientists and young student to look the slide, because I have seen many seminar and symposium and also the ICR, RAC committee and QRT committee. I am going to attend this type of committee in ICR. Then the presentation of the slide is very poor. And you see the Dr. Singh slides, it is very, and he has the matter within the slide and all the matter are visible. So it is a important factor to learn our scientists and students. Then the today talk is very much important for the students, faculty members, scientists, and also the policy planning makers and policy makers, because they have this how we can use this. It will deteriorate the soil health and also increase the pollution, but not if the fertilizer will use in balance and pK and also the normal recommended dose. This problem will not affect the soil health and productivity. And it is good thing more than 50 scientists and students that they have participated in this important talk. I am thankful to the organizer and also the student and scientist, especially Dr. Singh, for spare your valuable time for our foundation lecture. Thank you very much. And over to Dr. Arora.
Dr. Kohli, please. Thank you, sir. Dr. Kohli, please unmute yourself. Dr. Kohli, unmute yourself.
Yeah. Thank you, Dr. Sharma. As Dr. Bijay Singh just remarked that we won't be join each other for a cup of tea, but here I would request all of you to join for a group photograph just by switching on your video, so that in a tile view we can have a group online photograph.
Yeah.
So everybody please join.
Adda Sahib's face is not visible.
Yeah.
Yeah, here I see. Good.
Sir, he is also with us for a long time and he is associated in all the activities. We are thankful to him also, Dr.
Good.
बहुत ही अच्छा सी डॉक्टर साहब, so very alarming and timely. क्योंकि बहुत
Thank you,
wrong
sir.
है countrywide on the nano fertilizers and others and all that. So most of the facts you have brought to the forefront, and I am also really indebted, not a man of the soil chemistry or the soil fertility, but I was able to have the messages from your presentation. Excellent.
Thank you, Dr. बहुत चंगा लगा. I'm happy to see you after a long time.
हाँ जी, हाँ जी.
सभी लोग अपना वीडियो ऑन कर ले प्लीज.
Yeah.
एक बार. डॉक्टर गिरीश पटेल, डॉक्टर तोमर.
Yes, sir.
Hada sahab, you should come in the center of your screen. Yeah, that's way.
नवनीत, डॉक्टर पूजा, प्लीज फॉर 1 minute. डॉक्टर ओझा.
एक मैं अभी नंबर देता हूँ, ठीक है, आज नंबर देता हूँ बिहार का
थैंक यू सर, थैंक यू.
Thank you, everybody.
AK Singh for
Thank you, everybody. Now I
formal
request Dr. Atul, please.
Dr. Saini, thank you for joining.
Thank you, Dr. Arora.
Thank you.
Thank you, Dr. Bijay Singh. Nice presentation, sir.
हाँ जी.
Informative for the farmer. चंगा, बहुत चंगा लग गया आपको आज.
नहीं. I'm happy to see so many happy faces.
Yeah. We are also happy to see you,
Yeah.
sir.
Good. That's
I
very nice.
request Dr. Atul, the president of our society, to please propose a formal vote of thanks, sir.
Thank you, Dr. Kohli. And first of all, I will like to thank Dr. Bijay Singh ji for agreeing to our request and delivering such simple, in a very simple way. He has talked about the status and about the soil health, and very rightly, sir, you have always emphasized about the balanced use of N. You have said that we have to use only that much of N which is required by the crop. So I think this is the biggest message which we have to take it with ourselves after this lecture. I'm also thank you for Dr. D.K. Sharma, who is our patron, and sir, you have always been very kind to shower your blessings whenever we have approached to you. I am also thankful to Dr. Kohli, Dr. Arora, and Dr. Vikas for organizing such a wonderful event and making Dr. Bijay Singh ji to agree for this lecture. Last but not least, I will like to thank all the participants who have joined us, and they have been always supporting to us and always joining with a great always whenever we have organized any events, we have got a lot of support from students and scientists from different organizations in our country. So once again, I thank all of you for joining, and we look forward for our future association also. Thank you all.
Thank you very much. Thanks a lot, Kohli sahab. It was wonderful to meet you all.
Thank you,
From
sir.
Canada.
Let's hope we'll meet again in November, huh?
Okay.
Yes, sir. Yes.
Yes.
Okay, sir. Good night, sir.
Good night.
Good night.
Good
Good night.
night.
Thank you, everybody.
For me, it's good night. For you,
Yeah,
it's
yeah.
not good night.
Yeah. Thank you, sir.
Okay, thank you very much for giving
Thank
the
you, sir.
opportunity. And I
Thank
thought